Look up at the night sky tonight. You see stars, right? And beyond those stars, you know there are galaxies. And beyond those, well, more galaxies. From down here on Earth, it's so easy to look at the universe and just see this enormous, chaotic mess of objects sprinkled totally at random through the freezing dark of space. But what if it isn't? What if there's a colossal, completely hidden architecture secretly governing absolutely everything we see? Welcome to Curious Orbit. Today, we're diving into a profound cosmic mystery that is going to completely shatter your perception of a random universe.
So, let me ask you this. What actually happens if you just zoom out forever? Let's say you start with a single star. Zoom out, you get a solar system. Zoom out again, a swirling galaxy. Now keep going. If you fly past the local groups, past massive clusters of galaxies, moving literally millions and billions of light years away, what do you see? Does that random scattering just go on forever into the infinite void? Or does a highly structured, unimaginably massive pattern suddenly emerge from the dark?
Section 1. Zooming out. The hidden pattern.
Well, as it turns out, the universe doesn't look random at all when you step back and view it on the absolute grandest scales. Think of it like this. Imagine taking a blank piece of paper and just sprinkling thousands of tiny dots all over it. If those dots were truly random, you'd get a pretty even, uniform spread across the page, right? But our actual universe? It doesn't work like that. Instead, galaxies actually like to gather together. They pull into these incredibly tight clumps and localized groups. And over immense distances, those groups merge into much, much larger clusters. The end result? It's this highly complicated, unimaginably vast pattern that completely defies our earthly idea of a scattered cosmos. Scientists call this staggering pattern the cosmic web. But, okay, let me stop right there for a second, because we need to clear up a major misconception. When I say web, please do not picture a literal web. It is absolutely crucial that we throw out the idea of some giant space spider's web made of solid physical strings. That's not what this is. The true cosmic web is a vast, invisible framework made up of incredibly diffuse gas, dark matter, and large-scale galaxy distributions. It's fluid, it's dynamic, it's a pattern created by immense gravity and flowing matter, definitely not some physical net holding the universe together. Section 2. Clusters, filaments, and voids. So what exactly is this colossal pattern made of? Let's break down the anatomy here. On one extreme end of the web, we have galaxy clusters. These are straight up some of the largest gravitationally bound structures in the entire universe. We are talking about massive cosmic environments containing hundreds, sometimes even thousands of individual galaxies, all locked together in this intense gravitational dance. But here's the crazy part. These clusters aren't just collections of stars. Right alongside those glowing galaxies, there are staggering amounts of invisible dark matter, plus vast clouds of ultra-hot gas. And when I say hot, I mean temperatures soaring into the millions of degrees, just radiating intense energy out into the cosmos. Now jump to the complete opposite extreme, and you find cosmic voids. These are enormous, mind-boggling regions stretching for hundreds of millions of light years that contain, well, almost nothing. Very few galaxies. They are the great, lonely, empty spaces of the universe. Just imagine traveling at the speed of light for literal eons and encountering almost no massive structures, just an endless expanse of dark. But crucially, when cosmologists say empty, they don't mean completely void of all matter. These regions still contain extremely diffuse gas and dark matter. It's just an area where gravity basically failed to pull material together into dense galactic cities. And then, bridging the gap between those two extremes, connecting the dense clusters across the terrifying expanse of the voids, we have cosmic filaments. Think of these as enormous, thread-like strands of matter stretching for vast distances. These brilliant cosmic highways contain galaxies, entire galaxy groups, and diffuse gas steadily flowing through the network. They provide this incredible, large-scale environment where galaxies can actually form, interact, and evolve over billions of years. They are, quite literally, the grand, glowing rivers of the cosmos. Okay, so we've got incredibly dense clusters, unimaginably massive voids, and vast filaments stretching between them. But seeing all of this immediately brings up a huge, unavoidable question. What invisible force is actually orchestrating all this massive cosmic traffic? Like, what ancient, unyielding power physically built this giant web in the first place? Section 3. Dark matter and ancient gravity. Well, the master architect behind the grandest structure in the universe is something we can't even see. It's dark matter. Dark matter acts as the invisible gravitational framework of the universe. And honestly, It remains one of the deepest, most compelling mysteries in all of modern cosmology. We can't see it directly, not like we see the radiant glow of a star or a beautiful spiral galaxy. Yet, we know with absolute certainty that it's out there. Why? Because we can detect its profound gravitational pull on everything else. Our leading cosmological models show that dark matter played the absolute major role in forming the cosmic web. It essentially provided the unseen scaffolding that the entire visible universe was built on. But, the cosmic web didn't just pop into existence overnight. It's the result of an epic, breathtaking evolution. In the incredibly young, early universe, things were actually much smoother than they are today. But not perfectly smooth. There were these tiny, microscopic density fluctuations, just microscopic regions that happen to have a tiny bit more matter than others. And over immense stretches of time, we're talking billions upon billions of years, ancient, relentless gravity went to work. It amplified those tiny differences. Regions with slightly more matter simply pulled in more matter. And over staggering timescales, those minuscule quantum quirks grew and blossomed into the complex, awe-inspiring network of clusters, filaments, and voids we see today. Now, that is a brilliantly beautiful theoretical model of how the universe evolved, but it creates a monumental practical headache for us humans. See, we're trapped right here inside the universe. We can't exactly step outside the borders, set up a giant camera, and snap a nice wide-angle photo of the whole cosmic web. So, how do astronomers actually map an invisible, colossal structure from the inside?
Section 4. Mapping the invisible universe.
This is where the brilliant detective work of modern astronomy really shines. Scientists have to painstakingly piece together the architecture of the cosmos using incredibly precise observations. And they use a whole arsenal of clever tools to do it. First, by measuring the exact distances and three-dimensional positions of millions of individual galaxies, they can actually watch the skeleton start to emerge. They map out the massive galaxy clusters that anchor the whole network. They also study something called gravitational lensing, which is this mind-bending phenomenon where the immense gravity of unseen dark matter physically warps and bends the light from distant galaxies behind it. And finally, using powerful telescopes, they can trace the incredibly faint glow of diffuse gas flowing right along those cosmic filaments. But when you're mapping something this vast and mysterious, it's really important to be clear about the boundaries of what we actually know. We have physical facts that we can directly observe. Things like galaxy positions, that bending of light from gravitational lensing, and the distribution of cosmic gas. Then we take those facts and build brilliant theoretical models, using dark matter frameworks and the math of early density fluctuations to explain what we're seeing. But guys, there are still massive, profound unknowns here. The true, physical nature of dark matter, still completely unidentified. The underlying cause of dark energy tearing it all apart, still a profound mystery. Science is this ongoing, thrilling process of observing reality and slowly, steadily filling in those giant cosmic blanks. Which naturally leads us to another big question. We've been talking about vast expanses of nothingness, invisible matter, and mathematical patterns stretching across billions of light years. To a person just trying to go about their day down here on Earth, why should we even care? What does this colossal web actually mean for us? Section 5. Dark energy and our place. Well, understanding the cosmic web isn't just about drawing a pretty map of the sky. It is literally about uncovering the fundamental laws and the ultimate fate of the universe itself. We know that the expansion of the universe is actively accelerating, and it's being driven by a deeply mysterious force called dark energy. The cosmic web provides us with a universe-sized laboratory to study this. By looking at exactly how this massive structure developed while the universe was simultaneously expanding, scientists can test their models, investigate dark energy, and peer directly into the forces that will ultimately dictate the end of time. Plus, mapping this web acts as a literal cosmic time machine. Because light takes time to travel through the sheer, mind-boggling vastness of space, when we look at a galaxy a billion light years away, we are seeing it exactly as it was a billion years ago. So when astronomers map the darkest, most distant reaches of the cosmic web, they aren't just looking across space. They are looking deep, deep backward through cosmic history. They get to witness completely different evolutionary stages of the universe in real time, literally watching ancient gravity shape matter over eons. But honestly, for me, the most awe-inspiring, perspective-shifting realization is this. We are not looking at the cosmic web from the outside like it's in a museum case. We are living inside it. Our solar system is just one tiny, fragile little speck orbiting inside the Milky Way galaxy. The Milky Way is just a small part of our local galaxy group, and that local group is firmly, deeply embedded right inside the sprawling filaments and vast gravitational framework of the cosmic web itself. We are an active, living, breathing part of this colossal structure.
So, I want to leave you with this final thought to ponder. If you could explore one part of the cosmic web, would you visit a massive galaxy cluster or an enormous cosmic void? Tell us your choice in the comments and subscribe to Curious Orbit for more space science.